This is where I will be at the end of this program, in a perfectly ordinary-looking town in the south. Except this is no ordinary town. This place was once so secret that nobody knew it existed, full of people who didn't know why they were doing the job they were doing. People working on something that could still lead to the greatest conflict in human history. And the strange thing is, the story of how they got here, doing what they were doing, begins in a different place and a different time. When the people involved thought they were going through the greatest conflict in human history. A conflict so basic, it split those people apart forever. At least, that's what they thought. Until history brought them together again. In this town, 200 years after they had all gone their separate ways. That first conflict I mentioned happened in 18th century England, and it was all about having a sweet tooth. See, back then, the new rave taste craze that people went for like a drug was sugar. Okay, nothing wrong with that, unless you're a dentist, but it was how they paid for the sugar that caused the trouble. Because the sugar came from plantations here in the Caribbean. And all they wanted was a source of really plentiful labor. Well, there was only one source of really plentiful labor at the time: African slaves. And that's what the conflict was about. Anytime from 1500 to 1807, you wanted to get seriously rich, you went into the people-moving business. Demand for slaves in the Caribbean started astronomical and went up. Just too good an opportunity for English investors to miss.
Well, my dear, I must observe how particularly fine the garden's looking this year.
In 1770, 200 slave ships crossed the Atlantic. 30 years later, 1,200. Carrying people you could get $30,000 a head for. Mind you, it wasn't all plain sailing. Unspeakable conditions on board meant there was an average commodity loss, euphemism for death, of around 10%. But with profits like that, who cared? Overall, a total of 12,420,000 Africans were forcibly and profitably, quote, settled, unquote, in the New World. But even here on the Caribbean sugar plantations, and back in England, there were arguments about slavery almost from the start. Not, of course, on ethical grounds. Heavens, no. The row was about money.
The man's a buffoon, you know.
Sugar beet growers in Europe complained about slaves being cheap labor, which they were. Boring economists like Adam Smith said that slavery would reduce the workers' incentive. I expect it did. On the other hand, the English Treasury took the view that slavery produced more sugar, that produced more sugar taxes, and that was an easy source of revenue.
Times are not easy. Every day one hears of another estate being handed over to one of those obnoxious London brokers. The entire island should be theirs, I fear, before long.
The plantation owners argued they couldn't produce the goods without Africans, any more, they said, than the ancient Egyptians could have built the pyramids without slaves. Now, to the amazement of many at the time, an increasing number of dangerous radicals actually appeared to object to slavery on religious and moral grounds. Radicals with revolutionary tendencies, like the Presbyterians and other free church people, some of whom went so far as to force their members to free any slaves they had. By 1787, these reformers had started organizing with the first Slavery Abolition Society. One of the society's leading English lights was a nonconformist called Samson Lloyd. If you know Lloyd's Bank, it's that Lloyd. The Abolitionist Society had good reason to sing the praises of Samson Lloyd because, well, with his support you had a lot of clout. because he had a lot of money. Because back in the early days of the Industrial Revolution, he was in the very profitable business of holding things together. Well, he made nails. Well, he actually made wire first. Okay, the subject of wire may leave you just a little underwhelmed, but you try driving into New York without wire. I refer, of course, to the wire holding up this bridge, the final link completing the Union of the United States. America held together by wire, thanks to a German immigrant called John Roebling, who was overwhelmed by the idea of wire cable suspension bridges. Alas, his potential backers, some people called Washburn and Co., were underwhelmed by the idea, so Roebling went ahead alone. His first suspension bridge at Niagara had turned on-site cable spinning into a household word with anybody who wanted to hang anything heavy. Nobody had ever tried making wire ropes his way before. What Roebling did was to spin all the parallel wires into a cable and then hold them together with a binding wire set at intervals all along the cable. It was that idea that got Roebling the big one, the Brooklyn Bridge contract. On opening day 1883, it was the longest bridge span in the world, held up by only 4 steel cables 15 3/4 inches thick and 3,568 feet and 6 inches long. All there is between you and the river. Around about this time, the telegraph gets invented and ups the demand for wire that will survive outside in all weathers. So in 1860, a Brit called Bedson comes up with a new way to protect and strengthen wire. Nothing very complicated, you just dipped it into a bath of molten zinc. Of course, Bedson gave it the high-tech name of galvanizing, and there ought to be some around here somewhere. Ah, this is galvanized. Bedson's galvanizing trick was just one bit of a whole wire-making process that he dreamt up that would turn 25 pounds of metal into galvanized wire in 15 seconds flat. You're not impressed? In 1868, I'll tell you who was. Washburn and Company. You remember the boring lot that turned Roebling down? Well, anyway, Washburns took Bedson's idea and brought it to America. And in doing so, killed off the Wild West. See, 6 years earlier, the Homestead Act had started giving 160 acres free to anybody over 21 who'd settled it. You lived on the land for 5 years, and it was yours. One minor problem, others had got there first. The cattlemen, for whom public land had always been free grazing land, and who were not in the least inclined to give up this profitable state of affairs without a fight. So they fought. The sodbusters won in the end, thanks to Washburn and Co. and the galvanized wire they produced, because in 1874, some people in DeKalb, Illinois, came up with an amazing new idea for cattle control. Mass-produced, it was basically just 2 strands of twisted galvanized wire, held together at intervals by small turns of wire with sharpened points that stuck out sideways to form a kind of barbed spur. It was barbed wire that ended the range wars and killed off the Wild West because it killed off the cowboy. So with farmland protected from animals like this, the face of America would change and the country would become the breadbasket of the world, thanks to corn. By the 1880s, canned corn was keeping the industrial cities alive when disaster struck. For some reason, the cans turned the corn black. Nothing worked until they tried dipping the cans in a free byproduct of Bedson's old galvanizing process, molten cadmium. Worked a treat. Then cadmium turned out to be toxic enough to kill you. So it was goodbye cadmium. Almost. Because a few years later, it turned out to have another property that was just what was needed in an industry a million miles from nails, wires, bridges, fencing, canned foods, or anything else I've mentioned so far. And its use by that industry here would bring together again those 2 historical trails that had separated 200 years before over the slavery issue. So remember cadmium, where this trail ends. Well, I go back to take the pro-slavery trail through history to meet myself again, here, if you see what I mean. The modern sugar industry starts back in 1650 when sugar was worth a king's ransom. By 1750, it was just an expensive luxury. The kind of raw material so valuable, a country would go to war because of it. The reason sugar shares were the hottest thing on the market was obvious. The Industrial Revolution had put a lot of money into the pockets of the new factory workers, and they spent most of it on the Coca-Cola of the time, sweet tea. When you had a calorie intake as low as theirs, sugar gave you a real buzz. So in 1807, when Britain and the US banned the slave trade, it was, to say the least, a bitter blow to the sweet tooth market. Plantation owners and investors were jumping out of the window, sugar exports dropped like a stone, slaves started leaving the plantations and, unheard of, refusing to work. The situation was catastrophic. It was enough to drive a planter to drink. You won't be surprised to know, given the bad jokes I make, that drink was where the solution to the problem would come from, to save the plantation owners and put the rum in rum and coke, thanks to a contraption called a multiple effect evaporator, invented in 1843, the sugar maker's sweet dream. It worked just like that steam cooking thing over there. You see how on top of the fire there's boiling water and then two food containers, and the top one cooks with the steam from the next one down, and that one cooks with the steam from the bottom one, using the steam twice over, like the multiple effect evaporator I mentioned. And using steam twice over meant they could boil out sugarcane juice with only half the fuel. So, a lot of cheap Caribbean sugar, so a lot of molasses, boil that down, a lot of rum. The evaporator idea really started with a Scotsman who discovered that steam was so scalding hot because it kind of absorbed heat. He told this to his pal, James Watt, who used the data to design a better steam engine, which was going to make Watt a lot of money, if only he could afford to build a lot of engines, for which he was going to need a lot of money. And then he found a guy who was coining it, a fellow with a button factory called Bolton. They went into business together, and you know the rest. But why was Bolton coining it from buttons? Because the other thing you can do with a steam-powered button stamping machine, which Bolton had invented, was stamp coins. So Bolton was doing that for America, France, Bermuda, India, Russia, Spain, Denmark, and Mexico, making money hand over fist. Bolton's real upmarket artistic stuff was medallions, one of which, ironically enough, was to commemorate the abolition of slavery. Bolton's new mint in Birmingham ended up with 8 coin stamping machines that would produce any size of coin you wanted. Each machine needed only 1 worker, and the coins came off the machines at 200 a minute, 50 times faster than the old way. So fast, Bolton created a copper shortage. And then Bolton got the big moneymaker he'd been angling for all along, the contract to make official national currency for the English government. Now, the trouble with English money at the time was most of it was fake. So in 1797, Bolton really cleaned up when he produced 4 coins that were so good, the counterfeiters kind of gave up. Here they are. Farthing, halfpenny, penny, 2pence. So, now there was money you could trust, the government decided in 1824 to risk some more new coins. This time they brought in an Italian called Pistrucci to do the designs. Here's one of his. See that new national emblem idea? That really caught on. That's why we have them on modern coins. Anyway, Pistrucci made coin design really high-tech with one of these, a pantograph. I'll use this medallion to show you what he did. First he designed a plaster model, and then he plated the model to make it hard wearing, and then very carefully retraced the design of the model with the pantograph stylus, so that over there a knife carved the same design to scale on a steel die, a bit like this. And then he used the die to stamp out the coins. But did you notice I said plated the model? That's because the latest scientific miracle at the time was electroplating. Which brings me, alas, to one of history's greater bores, a self-made English science hero called Michael Faraday. Faraday was one of those people most charitably described as painstaking. So when he heard that some Italian had come up with a new way to use electricity to electroplate, Faraday couldn't wait to see how it worked. The Italian idea was one of those flashes of genius you wonder why you didn't think of first. It was so simple. If chemicals could make electricity, which they did in a battery, could you turn the thing the other way round and make electricity do something to chemicals? The Italian, a fellow called Brugnatelli, and also a pal of Volta who had invented the battery, did the following. He put an object connected to a battery in a copper solution in which there were also bits of copper also connected to the battery. And something amazing happened. The atoms in the copper solution deposited themselves all over the object, copper plating it. And at the same time, as the solution lost its atoms, they were replaced by atoms from the bits of copper. The question for Faraday was, why? In 1833, he discovered that it needed a particular amount of electricity, depending on the metal, to get the whole thing to happen. Which meant that there had to be a relationship between the mass of the metal and the amount of electricity you needed. In other words, Faraday reckoned there had to be some kind of link between mass and electric charge. Which brings us, temporarily, to television. Because by 1889, somebody had discovered cathode rays and found that you could move them around too if you controlled them with electric fields, which is how your TV works. Look. So maybe cathode ray particles had mass as well, because the electric field was moving them around, just like electricity did to the atoms during electroplating. In 1910, a fellow called Thomson shot neon particles through electric fields, which, sure enough, affected the particle flight path. But the weird thing was, the neon particles split into two streams, as if they had two different masses, one lot lighter than the other, because Thomson saw that one lot went further than the other lot. Thomson had discovered isotopes, atoms with more than one mass. By 1919, you could use this trick to separate out isotopes with masses only 100 millionth different. The trick is called mass spectrometry, and with it you can identify with the most incredible precision anything by firing particles of it through electric fields and watching how far they go, which tells you their mass, which tells you what they are. Which means you can do all sorts of good things like forensic investigation by identifying minute traces from a scene of crime. Or tag an isotope tracer onto the medication somebody's taking and watch where it goes as the drug is absorbed by their body. Or identify terrorists, because you can analyze the most minute residue of explosives they might happen to have on their hands. Which brings me to end here, where the separate ways of the slavers and the anti-slavers finally come together. Because this pro-slavery trail I've just been following led to mass spectrometry being used to separate out the high-fission isotopes of uranium-235 from the abundant but less effective uranium-238. And thanks to the trail triggered by the anti-slavery people, cadmium, you remember the stuff the canners used to plate the insides of the cans with, cadmium ended up being used as a neutron absorber in the rods controlling the speed of the fission reaction of the first nuclear pile. Remember this place? So, having gone their separate ways, split apart by the most explosive issue of the 18th century, history finally brings the two sides together again, here, at the birthplace of the most explosive issue in the 20th century, atomic weapons. And that's why I said this was a secret place. Because the Manhattan Project that started in 1943 and made the bomb dropped on Hiroshima happened back in that lab. Here in the town where separate ways came together. Oak Ridge, Tennessee.